Imagine standing beside a machine so enormous that a normal crane would look like a toy next to it. Its steel structure rises hundreds of feet into the air. Massive cables disappear into the sky, while enormous hooks hang above objects weighing thousands of tons. This isn't science fiction. These are some of the most powerful cranes ever built, designed to move structures that seem far too heavy for any machine to lift. Before we explore how these engineering giants work, make sure you subscribe to Railforge and turn on notifications. Here we explore the world's most fascinating machines, engineering projects, and technologies. Now let's get into it. When most people think of a crane, they imagine a construction machine lifting concrete beams or steel sections. But the largest cranes in the world operate on a completely different scale. Some heavy-lift cranes are designed to move thousands of tons in a single operation. They can be used to construct bridges, assemble massive ships, install offshore equipment, and move enormous industrial structures. So how is this even possible? The answer begins with one simple principle: leverage. A crane doesn't simply rely on engine power to lift a massive object. Its entire structure is carefully engineered to distribute forces through steel beams, cables, pulleys, counterweights, and foundations. Every component has a specific job. The boom provides reach. The cables carry enormous tension. The pulleys help distribute the lifting force. And the counterweights prevent the entire machine from tipping over. But as the lifting capacity increases, the engineering becomes much more complicated. Imagine trying to lift an object weighing thousands of tons. The crane itself has to remain stable while carrying a load that may weigh more than an entire building. That's why some of the world's largest cranes are built with enormous counterweight systems. These counterweights can weigh thousands of tons themselves. They balance the load on the opposite side of the crane and keep the center of gravity within a safe operating area. But there's another challenge. The crane doesn't just have to lift the object. It may need to move it. A massive load might need to be raised from the ground, rotated, and positioned with centimeter-level accuracy. That means engineers must control the crane extremely carefully. Even a small movement at the top of a huge structure can translate into a much larger movement at the end of the load. This is why modern heavy-lift cranes use sophisticated computer systems. Sensors constantly monitor the crane's position, load, wind conditions, cable tension, and structural forces. Operators can see exactly how much weight is being lifted and whether the machine is approaching its operating limits. Wind is another major problem. A giant crane can have an enormous surface area. When strong winds hit the structure or the suspended load, they create forces that can become dangerous very quickly. That's why heavy lifting operations are carefully planned around weather conditions. Sometimes the crane simply has to wait. And when a lift finally begins, every movement is carefully coordinated. The load may rise only a few centimeters at a time. Engineers watch the cables. Operators monitor the sensors. Ground crews communicate with the control room. And everyone knows that there is almost no room for mistakes. One of the most impressive applications of these cranes is shipbuilding. Modern ships can be assembled from enormous sections. Instead of constructing every part piece by piece, shipyards can build large modules separately and then use giant cranes to lift them into position. This dramatically reduces construction time. The same principle is used in offshore engineering. Massive cranes can install equipment on offshore platforms, wind turbines, and other structures far from the coast. In some cases, the equipment being lifted is so large that transporting it and positioning it becomes an engineering project by itself. And this raises an important question. Why not simply build everything smaller? Because large components can often be stronger, more efficient, and faster to install. But there is a limit. As structures become larger, transportation becomes more difficult. Cranes become more expensive. Foundations have to become stronger. And every additional ton increases the forces involved. This is why the world's largest cranes are not simply bigger versions of ordinary construction cranes. They are highly specialized machines designed around specific engineering problems. Some are mounted on enormous vessels. Others operate in shipyards. Some are built for offshore construction. And some are designed specifically for assembling bridges and other megastructures. Their scale is difficult to appreciate until you see one beside a normal vehicle or person. A worker standing next to one of these machines can look almost microscopic. But perhaps the most impressive part isn't the size. It's the precision. Lifting thousands of tons is one thing. Moving thousands of tons exactly where engineers want it to go is something completely different. A heavy lift operation may involve hundreds of calculations before the machine even starts. Engineers calculate the weight of the load. They study the center of gravity. They analyze the lifting points. They calculate cable forces. They consider wind. They examine the ground or vessel supporting the crane. And then they simulate the entire operation. Only after everything has been checked does the actual lift begin. This is what makes giant cranes so fascinating. They combine enormous mechanical power with incredible precision. A machine capable of lifting thousands of tons must also be able to move that load slowly and safely. And as humanity continues building larger ships, taller structures, bigger offshore platforms, and more ambitious infrastructure projects, these machines will become even more important. The world's largest cranes are more than construction equipment. They are tools that allow engineers to build things that would otherwise be almost impossible to assemble. So the next time you see a massive bridge, giant ship, or offshore structure, remember that somewhere behind that project may be a machine capable of lifting thousands of tons. A machine that turns impossible-looking engineering problems into carefully controlled movements of steel. And perhaps the most impressive thing about these cranes isn't how much they can lift. It's how precisely they can place it. Thanks for watching RailForge. If you enjoyed this engineering story, subscribe and turn on notifications for more incredible machines and mega projects from around the world.